Hello everybody, we are going to talk about hypothesis testing, but before we quite get into that, we have to know a little bit of background information in order to do hypothesis testing. To be specific, we have to know a little bit about random variables and their probability distributions, as well as a very important distribution called the normal distribution, as well as a very important theorem called the central limit theorem. And all these things are going to tie together when we get into doing hypothesis testing. We're going to use all these quite extensively. So the first thing we need to talk about are random variables. So a random variable is just a variable whose value is unknown. Another way you can think about this is a variable that is the outcome of some kind of statistical experiment. So I have two examples here. I say let x equal a single coin toss. So we don't know what the value of x is, but we know all of the possible values that it can take on. We just don't know what the actual value is because it's a random variable. But we can say that, well, the probability that x is going to be heads is a half, probability that x is going to be tails is also a half. So we don't know what the actual value is, but we know about all the values it can take on. In other words, we call this the domain of a random variable. For discrete, or for these variables here, it is the different values that it can take. So think of a dice toss that I have here. We have possible values here that x can be 1, 2, 3, 4, 5, or 6, and each of these are equally likely. And just a point of notation is that this capital X is the random variable. If you see lowercase x, that usually means a very specific value of the random variable. Speaking of random variables, we can broadly separate them into two different categories. We have discrete random variables and continuous random variables. So discrete random variables, as the name implies, can only take on a countable number of values. So picture things like doing a coin toss or a dice roll. They're a very discrete number of values. Even this interesting example, it's used a lot in statistics textbooks. It's a seminal problem that you'll see in statistics textbooks. If you've taken a course on statistics, you'll probably have some question like this: the number of defective light bulbs in a box of 100. So the different outcomes here are light bulb 1 is defective or not, light bulb 2 is defective or not, light bulb 3 is defective, and so on. This is an example of a discrete random variable. So we have discrete random variables, and we also have continuous random variables, and these random variables can take on an infinite number of values within a given range. So things like the heights of humans is continuous, things like lengths of flower petals, or the time to check out on an online cart. If you're buying something from an online retailer, the time to check out is also an example of a continuous random variable. Right? So think of things that are real numbers, for example. Usually continuous random variables describe properties that are real numbers. So heights of humans, for example, are real numbers. Whether you measure it in feet and inches or centimeters, they can take on an infinite number of values within a particular range, or they don't even have to be bounded. They can just go from negative infinity to positive infinity. It depends. And discrete random variables then can usually describe properties of things that are integers or things that you can actually list out and enumerate. So that's just kind of the way you can think. If you ever have a question of whether a variable is discrete or continuous, think about what its possible values could be. Can it take on an infinite number of values? If so, then it's usually going to be a continuous random variable. Okay, so now that we know what random variables are, let's talk a little bit about what a probability distribution actually is. So it's really just a representation of the random variable values and their associated probabilities. So you're going to encounter two things, different kinds of function. There's probability mass function, we say PMF for discrete random variables. We have probability density function for continuous random variables. So let me give you some examples. So here's the probability distribution for a single coin toss. So on the x-axis, we have all of the different possibilities. In other words, the domain of the random variable. So heads and tails are the only two possible values here. And on the y-axis are their associated probabilities. So heads has a probability of 0.5 or a half. Tails has a probability of 0.5 or a half. In another example, we have a single toss of a six-sided dice. again, we have numbers 1, 2, 3, 4, 5, 6, and their associated probabilities. Each of them have a probability of 1, 6. So these are examples of, actually these two are examples of something called a uniform distribution. In other words, for a uniform distribution, each outcome is equally likely. So for heads and tails, they're both equally likely for each of the dice toss. For a six-sided dice, each of these outcomes are equally likely. So we call these the uniform distribution, specifically the discrete uniform distribution. And these two are examples of probability mass functions because they associate a probability to each possible discrete outcome. When we talk about the normal distribution soon, that is going to be an example of a continuous distribution, so we can't talk about PMFs, probability mass functions, we have to talk about the PDF, or probability density function. So this is really just what a probability distribution is, and it's quite easily representable in a nice pictorial format. I think that tends to work quite well for showing what actually is going on with these probabilities. So now these probabilities are great, but they have some rules. So let's talk a little bit about some of the rules of these probability distributions. So all of the probabilities in a probability distribution have to be between 0 and 1. Probabilities in general have to be between 0 and 1, including both 0 and 1, right? So probability of 0 is impossible, probability of 1 is certain. Anything that goes outside of those ranges doesn't really make sense in terms of probabilities. The other thing is that the sum or the integral over the domain of the random variable, in other words, all the probabilities of a random variable, that has to equal 1. So if we're talking about discrete random variables, that's the sum. If we're talking about continuous random variables, that's the integral. But don't worry, we're not going to use any calculus. So what I mean by that is we look at the possible outcomes of heads and tails. If we sum them up, we should get 1. And intuitively, you can think of this as we're guaranteed to observe something. Something is going to happen. If we do a coin toss, we're either going to get heads or tails. That's essentially what the second rule of the probability distributions is trying to say. Is if we if we look at our random variable and it's a coin toss or a dice toss or something, we're guaranteed that something is going to happen. That's why the sum has to. That's why everything has to sum to 1, and you can see for the dice toss, 1 6 plus 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 1 6. That's 6 6. In other words, 1. So these are actually probability distributions because all the probabilities are between 0 and 1, and they sum up to 1. If we had a continuous distribution, we would use the integral. So that is where I'm going to stop here for random variables. So this is just to introduce you to the concept of what is a random variable and what are probability distributions to begin with. And then now we're going to look at some very important distributions and theorems in statistics that even allow you to do hypothesis testing. Okay, so just to do a quick recap, we talked about what a random variable is, a variable whose value is like the outcome of some kind of statistical experiment. In other words, we don't really know what the value itself is, but we know about the different values that it can take. Then we talked about the different kinds of random variables, discrete and continuous. Talked a little bit about what probability distributions are. They're just representations of the probabilities, and then I should say the domains of the random variables and their associated probabilities. And we talked a little bit about some of the rules. Probabilities have to be between 0 and 1, and they have to sum up to, all the probabilities have to sum up to 1. So that is all with random variables, and so we're going to get into probably the most important distribution used in statistics and many other fields called the normal distribution.